Hey everyone, today I'll be talking about Leetcode 1261, find elements in a contaminated binary tree. So we're given some tree, it has all negative ones, so it's been contaminated apparently. And to recover it, to make it not contaminated anymore, we have this rule set. So the root's value is 0, and then for any given node's value x, the one to the left will be 2 times x plus 1, the one to the right will be 2 times x plus 2. So kind of like looking at these diagrams here, so we have this, and we know this becomes 0 because that's our base rule, and we know to the left it's 2x plus 1, and then to the right it's 2x plus 2, so that's true. Go to this one, 2x plus 1 is 3, 2x plus 2 is 4. So that's recovered. You could do this a number of ways. The naive way, and it's actually easy to do and it does work, is you can kind of like recover this tree, like build and mutate all the values, and then you could just do binary search and search through each tree. But that would be a on constructor and a o log n find, and it can actually be better. We can have this find be constant time. So when we think of constant time, we usually think of hash map, hash set for constant lookups. So we're going to do that, and we're going to have a set. And we're just going to mark it as private for now. We're going to have a set in the class. Now, and let me go ahead and also get rid of this here. Hold on. Okay, there we go. And then what we want to do is we want to construct this using this rule set and populate the set. So ideally the set should have every recovered value in it. So for this find, we can make it O1, right? We could just simply go set contains target, because we're going to assume we've built it at this point. So in the constructor, we want to initialize the set, just make it a new hash set. And we also want some helper method, which I'm going to call DFS. And basically this DFS method is going to build the root. And it needs to have some base truth, and the base truth is that the root value is always going to be 0. So let's pass in a 0, and we'll make the function definition here. And it can be void because it's just a builder, a recursive builder. It doesn't have to return anything. It's going to take some root, and it's going to have some current value. So I'll call this x rather, because if we look at this rule set, they're talking about x, so we'll just do it exactly how this is structured. And so we've covered rule number 1 here, just by passing in the 0 at the beginning. That's our root. So the root is 0, right? So we do need a base case because we don't really want to add anything if this root doesn't exist. And there's actually nodes, if you look here, it does stop eventually. So if root is null, we just simply want to break or return. Next, what we want to do is we want to add the current x into the set. So we'll go this.set.add x. We do this because if you think about it, when we start, it's 0, right? We have to add that root. It'll be 0, it'll go here, and it'll add it to the set. So then we want to go left, and we're going to go right, and we want to start to recover this tree. So, and it'll terminate as so long as, or it'll terminate when the root is null eventually. So we want to go left first. So we'll call this recursively, and we'll go left. So this will be root left. If we look at these rules, we're covering the second rule. So going left is 2x plus 1. So we're going to do that. We're just going to literally copy this. So 2 times x plus 1. And then if we go right, it's 2 times x plus 2. Like such. So following this, this is good as is. Because it's going to go through, it's going to populate it. If one of the nodes is null, it's just going to stop, and it'll just kind of like bubble through and like populate that set. Then once it's finished, it's reconstructed the tree, put all the values in the set, and then this is O of 1 here. So let's run this. Okay, that looks good. Let's submit it. And yeah, it looks like this is actually really good. So let's talk about time and space complexity. I kind of went over it a bit, but this is an object-oriented solution. This is a class, so there's multiple methods. So let's talk about the time complexity for each. So let's talk about this constructor here. So this constructor actually has an external dependency on this DFS function. And this DFS, to populate it, is just O of n, where n is the amount of nodes, because it terminates when it's null, right? So it's just going to be the amount of nodes in this tree. So I'm just going to call it O of n here. This find is actually O of 1 time here, because simply we're just looking it up in the set, right? And that's O of 1 lookup. Now for space, these are both for time, by the way. Space, all in all, is just going to be, and I'll put space up here, it's just going to be on. And the reason why is we have to store every single node's value in the set. So it uses on space, right? So yeah, I hope this is helpful. Try to make it a little bit easier than the medium they marked it as. So yeah, hope this helped. Thank you.